Hello everybody, welcome back to our continuation on the topic forces. Today we'll be discussing motion down a smooth inclined plane. Our very first question states that an object slides down a smooth plane inclined at arc sine 1/3 to the horizontal. Taking g to be equal to 10 meters per second square, calculate the acceleration of the particle, and we were given the option. Now for a smooth inclined plane or a frictionless plane, the acceleration is gotten by the formula g sine theta. So therefore, our theta will be equal to arc sine 1/3, which is equal to 19.47, and substituting, it will be equal to 10 times sine 19.47, which is equal to 3.33 meter per second square. We have another question for our 2004. It states that a body placed on a smooth plane inclined at an angle of arc sine 1/4 to the horizontal is projected up the plane with a speed of 3 meters per second. Calculate in meters the distance covered by the body before coming to rest. Take g to be equal to 10 meters per second square. Now, applying our laws of motion, the formula that's applicable in this case will be the one that states that v square is equal to u square minus 2as. Now, taking down our parameter, we know that v, which is our initial final velocity, is equal to 0 because the body ended at rest, and u is equal to 3 meters per second, and s will be unknown, which is the total distance covered. So using v square equals to u square minus 2as, we recall that a will be equal to g sine theta because of acceleration down a smooth plane is equals to g sine theta. So it will be equals to 10 times 1/4, which is equals to 2.5 meter per second square. So substituting all this in the original equation, that is v square is equals to u square minus 2as, 0 will be equals to 3 square minus 2 times 2.5 times s. Simplifying further and making s the separate formula, s will be equals to 9/5, which will be equals to 1.8 meter. Our next question is from NECO 2005, and it states that a young boy slides down from rest down a smooth plane inclined at an angle of 30 degrees to the horizontal at a time interval of 5 seconds. Calculate the distance covered by the boy. Take g to be equals to 9.8 meter per second square. Now, applying our various laws of motion, we are giving u, which is equals to 0, t, which is equals to 5, and a, and the formula that we can use that with this given criteria will be the one that states that s is equals to ut plus half at square. Knowing that we can get our acceleration with the formula g sine theta, so looking for our acceleration to be equals to 9.8 sine theta, which will be equals to 4.9 meter per second square. Now, substituting for u, t, and a in our equation, s equals to ut plus half at square, s will be equals to 0 plus half times 4.9 times 5 square, which will be equals to 61.25 meter, and the correct option is C. We have another question from November 1996. It states that a block of mass 0.5 kg placed on a smooth plane inclined at angle 45 degrees to the horizontal is kept in equilibrium by a force P Newton acting on the block at 60 degrees to the plane. Find the value of P. Take g to be equal to 10 meters per second. Now, our very first step is to represent our question in a diagrammatic form, and when we do that, we get the diagram as shown on the screen. Now, the component P of the plane is equal to the component down the plane of the weight 0.5 gram. That's if we resolve our P into its horizontal and vertical components, and we also resolve the weight of the body into its horizontal and the vertical component. Both horizontal components will be equals to each other. That is, the horizontal component of P will be equal to the horizontal component of our force or our weight. So therefore, P cos 60 will be equal to 0.5 g cos 45. And making P the subject formula, P will be equal to 0.5 times 10 times 1/2 divided by 1/2. Simplifying further, this will make P be equals to 10 times 1/2, which is equals to 5/2, and our correct option is E. Our final question states that a body of mass 8 kg placed in a smooth plane inclined at angle 30 degrees to the horizontal is acted upon by an upward force of magnitude 50 Newton at angle 45 degrees to the line of greatest slope. Find the 1. Acceleration of the body, 2. Magnitude of normal reaction, and we are to take g to be equal to 10 meter per second square. Our very first step is to represent our question in a diagram, and doing so we get the diagram as shown on the screen. Now for the very first part of our question, A can be gotten from F equals to MA or MA. Since mass 8 kg is given from the diagram, the resultant force will be equal to 8g sin 30 minus PS, which should be equals to 8 times 10 sin 30 minus 50 cos 45, which should be equals to 40 minus 35.36, which should be equals to 4.64 Newton. Thus F is equals to MA, so 4.64 will be equals to 8A, and dividing both sides by 8, A will be equals to 0.58 meter per second square. And for the second part of our question, R will be equals to mg cos 30 degrees, which will be equals to 8 times 10 root 3 divided by 2, which is 69.28 Newton. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.